I wanna show you another question. Here it is given in Turkish. This guy. Yes.
Hızlıca okuyorum. Endüvi direnci bir
Blah 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 blah. Let me change. As you see, that is a similar, looks like a similar question. Some parameters looks different. Instead of 240 volts, here it is written 110 volts. RPM speed is given, something is very different. The prior example was for a generator operation, but here it is shunt motor. Something really changed here. So, but the template looks like similar. Efficiency, blah blah, connection diagram. So I recommend you to solve this problem. I can, let me download this guy. Let me download. Where was it? Excuse me. Find 2016. Summer School Quiz 3. Yes, this guy. Okay, let me download it. And open. Houston. It looks different. I'm sorry. I have made a mistake. It was spring term, excuse me. But that was summer school. So let me download the other one. Here's summer school, yes. Let me download. Okay, here it is. The question looks similar. Let's try to solve this question. First, understand. A DC machine having 1 ohm armature resistance and having 220 ohms shunt resistance. That machine operates as a shunt motor and it is operated on a 110 volt network, and while it is supplied under this voltage and load, I don't know, we don't know the load yet, but the machine was operated at such a speed and draws such an armature current. Okay, let's draw what we understand so far. Shunt motor, some parameters, voltages, RPMs, and currents given. Let's draw the connection diagram. Here is the shunt machine operated as a motor. The prior example was generator. Here are terminals A1 and A2, and then this guy is a shunt machine, okay, and it is supplied from 110 volts power supply. Here is load current, here is shunt current, we don't know, but shunt field winding resistance was 220 ohms. Is it? Yes, shunt field winding has a 220 ohm resistance. Okay, that is 220 ohms. As you see, 110 volts supplied, and here is the 220 megs. I field is equal to 0.5 amps. We have already solved this. And here's armature current. And you see the armature current's direction because machine is operated as a motor. Here's the mechanical output, and the speed is given in the question, 950 and 5 amps armature current. Okay, do it. Here is 5 amps armature current is given. When machine is operated such a voltage, and while it is drawing such a current, speed was 950 RPM. Those are together 100 volts, drawing 5 amps and running at a speed of 950 RPM. Houston, everything looks clear. Yes. And field current is constant during all operations. Okay. Machine is magnetically linear and there is no armature reaction effect. Those are the assumptions. You know, while machine is operating, machine temperature rises, and then resistance values gets higher, so currents will drop a little bit, especially field current drops a little bit. And in these parentheses in the question it says that there is no field current change. It is assumed as constant during all operations. And now let's examine the first one, connection diagram, and to calculate load current. Okay, let me do it. Here's the connection diagram we have already drawn, and in the question calculate load current. He says load current for this node equation is equal to, for motor operation as you see, field current plus armature current. We have already calculated field current as 0.5 and 5 amps armature current. All those makes 5.5 amps. As you see, it is very easy. You got 20 points in that quiz right now. B. In starting process, to limit armature current at 20 amps, what is the required external resistance to be added the armature circuitry? Let me explain this. It is not clear, perhaps you are that is the second question you try to solve. This problem will be a little bit complicated for you. Now let's write Kirchhoff's voltage law first and understand the issue. Here's Kirchhoff's voltage law. Apply Kirchhoff's voltage law around the loop. Applied terminal voltage will be equal to summation of the voltages around the loop. Here is the armature resistance inside the armature. Here's the EMF inside the armature. So armature current times RA plus armature EMF is the Kirchhoff's voltage law around the purple loop. That is the voltages summed across the circuit. Now, during startup process, current will be startup current. Startup current, perhaps you remember from induction motor, is always startup current is always higher than rated current. Much more higher than rated current. Okay. That is the EMF when speed is 0. During startup, machine is at standstill, duruyor, and then you apply voltage. While it is at standstill, speed is 0, angular speed is 0. Remember EMF equation. Since this is 0, there is no EMF. Houston, during startup. So this guy is 0 and it is equal to Vt. Ladies and gentlemen, take care. Here looks the danger. Armature startup current is equal to terminal voltage minus Ra. Terminal voltage was given as 110 volts. Armature resistance was 1 ohm, I think, I'm not sure. Yes, armature resistance is 1 ohm. Terminal voltage, supply voltage is 110 volts. Here is 1 ohm. So 110 over 1 makes 110 amps. Houston, it would be large or small. We don't know what is the normal condition. Beep, 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 beep. It was in the operation given in A, the armature current was 5 amps. Houston, possibly it would be nominal or not, but that is a reasonable operating current. Reasonable operating current was 5 amps. And now Houston, machine is drawing 110 amps during startup. Very large current. Larger than 5. Houston, some precautions must be taken. So the question, let's turn back the question. During startup, to limit armature current at 20 amps, Houston, it was drawing 110 amps as you shown, but we want to limit it at 20 amps. How can you manage this? There's a clue. Add some external resistance to the armature circuitry. What do you mean? I mean, to manage this, I can add some external, let me say Rx, external resistance, in the armature circuitry. I want to limit the startup current, limit at 20 amps. It is required, it is given in the question. How can you manage this? It is very easy. You can imagine. Here is the equation. Vt is equal to current times Ra times armature EMF. When speed is 0, this guy 0. Houston, you have already added some external resistance here. Tata, Ra plus Rx. Houston, let me say that is RT, total resistance. So total resistance is equal to Vt, our armature currents. Let me say startup limited, say SL. Startup limited at 20 amps. And here's 150. That makes 5.5 ohms. Is it? Looks, yes. That is ohms. 5.5 ohms. Ladies and gentlemen, totally 5.5. This guy 1, so that is 4.5. Required external resistance to be added into armature circuitry is 4.5 ohms. That is the question. A bit complicated, but you start to learn how to approach those kind of problems. You get experience. Okay, we have calculated the second one. The time is getting limited. The Turkish solution of this problem is given in the video here. I have also attached in today's lesson. Here it is, this guy I have already given. Today I also add solution for the midterm exam we have done in last week. That is the one of the question I have announced the solution. Today I plan to make the solution of other question, and I will edit here, and then I will make an announcement that I have published all the answers of problem questions for the midterm. Now the time is getting consumed, so how can I manage? Let me the question D is a bit complicated, so I wonder if I skip that, but I could not, because here some parameters based on C, so we should solve the question C first, and then D must be go step by step. So this question must be solved. It's a bit complicated, but I have limited time. I want to stop here because of limited time. If you let me, I will continue later the solution, but Turkish solution is already published. You can watch there, or you can try later, because this part is a bit complicated for you, but the question looks like the prior one, this one. The question looks like this. So as you see, the problems would be much more different. Even if they look like similar, the problems, this guy was generator and that one is motor, and everything is different. Especially C is the most difficult question here, and that was new for you. I know you perhaps you cannot ready for this, but you are ready for this. Excuse me, you were ready for this, and we have already solved this. Because of time limitation, I want to stop solution here. Thank you very much for your attention and joining class. Bye bye.